In this video lecture, we're going to discuss epsilon NFA. So what's the difference between epsilon NFA and the ordinary NFA? So epsilon NFA is the same as with NFA, but the only difference is the epsilon move. If say epsilon move, it could go to another state without having or without carrying any symbol. Okay? So we call it E transition or epsilon transition. Again, the transition without consuming an input symbol. We could go from one state to another state without any symbol. Okay, without any input or without consuming any input symbol. Okay, so and also in E transition, using this E transition, it provides a convenient way of modeling the system. So there are instances it is easier to have an E transition to create that finite automaton. Okay, and due to empty move, the first string or first string of language may be an empty or epsilon. Okay, it could accept no string. Okay, it could end with having no string. It will be accepted. Okay, so for example, if we have epsilon A B epsilon A, so basically it's the same as with A B A. Since epsilon means no symbol, okay, empty. So if we're going to remove it, it will just be ABA. Okay. So same as with NFA, epsilon NFA is represented through a 5-tuple in formal definition. So Q is still finite set of all states. Okay. So sigma is still the alphabet. Okay. And this is also the total function. Transition function is the same as with NFA. Okay. And Q at 0 is still the initial state, and the F is the final state. So one example of NFA is this. Okay. So it accepts AB. Okay. So this is the ordinary NFA, but in epsilon NFA, we could have an epsilon between these two symbols. So AB in epsilon NFA, it could be drawn as A, then epsilon, and B. Okay, so we all know that from Q1, Q2, it could carry A going to Q2 and then go to 3 with B. So we have AB. Okay, so another example. So a finite will accepts the string A or B. So we're going to have two paths, one for A that accepts A and another path that accepts B. Okay, for epsilon NFA, we could have an epsilon going to another state from Q0, which is the initial state, go to Q1, go to Q3, and the first branch will carry A going to Q2, and in the second branch, it will Q3 to Q4 will carry B, and then from Q2 or Q4 will go to Q5 with an E transition. Okay. So example 3. So a finite item which will accept the string A or B or C. Okay. So we could have this. So A loop with Q0. So we say that accept string A. So that's why we have epsilon epsilon. If we have A, we could go to Q2 through epsilon transition. If it's B, so from Q0 to Q1, okay, epsilon, and then B loop, and then afterward it will go to Q2. And if it's C, so from Q0 to Q2 through epsilon transition, it will reach Q2, and then C will just loop within Q2. Okay, So again, epsilon transition, you could move from one state to another state without carrying any symbol. Okay, another example, draw a finite element which accepts the string A star, and we all know the A star is a loop. Okay, so in epsilon NFA, so Q0 to Q1, we have epsilon, and then Q1, Q2 is A, and then Q2 epsilon. This will be R loop for A in epsilon NFA. So A will go to, if it's another A, okay, and then afterwards, we could go to Q3 through the epsilon transition. And B star A, okay, so now we have B in our loop, then and we'll go to final state through A. Okay, so that's example 5. So that's it for this video lecture. Again, epsilon transition may go to another state without carrying any symbol. Okay, so see you on the next video lecture.